Hello, everybody.
Hello.
So you're probably here because you heard something about bots taking over the world. You might have even spent a weekend to hack yourself a bot, a Slack bot or Alexa skill or something like that sort. But there's a lot of difference between a weekend hack project and building a bot that really works, especially in enterprise. So today, we're very lucky to have Amir from Slack. He heads developer relations at Slack, and he's seen over 17,000 bots built on the Slack platform. And he has a lot of best practices on how to build bots. And after that, we're going to go into a session and show you how to use Google Cloud Platform to implement some of these best practices. And we're going to end with a really cool and fun demo. All right?
Awesome.
So with that, I'm about to begin, but I want to give a little bit of context first. There's actually three presentations related to conversational apps. Today is going to focus mostly on serverless and some of the application architecture. And tomorrow we have a session on a deep dive into natural language processing with API.ai. So if you like this talk, or even if you don't like this talk, go to the next one. And then the third one is how you actually build a voice bot. So today we're going to talk mostly on chatbots, but tomorrow you'll be able to talk about voice bots. So with that, I would give it to Amir.
Thank you. Thank you for having me. Hi, everybody. My name is Amir Shevat. I lead developer relations in Slack. Let's start by defining what bots are. So bots are a new user interface. They help you expose tools and services and workflows through messaging interface. Think of them as users that live inside your messaging app, but being powered by software rather than being powered by humans. So in the next few minutes, I'm going to walk with you about a few use cases and best practices about how to use and implement bots. Let's see a few examples. This is one of my favorite bots. It's called Amy Ingram. It's by a startup called X.ai in New York. And they're actually an email bot. X.ai developed this bot, and what it does, it schedules your meetings. So if you email me and say, hey, Amir, I want to meet next week, I add Amy to the email. It has access to my calendar, and it starts setting my emails. It starts setting my meetings through email. It sends about 400 emails a month for me. So it saves me a lot of business processes that I don't need to do. People send thank you letter for Amy and CC me. They're not aware that it's software. So it's pretty awesome and amazing to have this companion that helps you do things. Another bot that I really like is the Stats bot. It actually connects to the Google Analytics API and surfaces reports inside Slack. So you can actually, this is my blog, as you can see, is not performing very well. But I can actually talk to the bot and ask it things like, who are my users, where they're coming from, have a conversation about my statistics. And I don't need to do the context switching between Slack and Google Analytics. I get everything in a conversational interface. At the technical level, there's a few differences between bots and applications that you know, for example, for Android. And the contrast is that bots are not binary that are installed on your client. We don't install anything on your client. We connect services. So your bot actually lives on Google CloudFunctions or any other hosting provider, and it gets event about what's happening in Slack for your users, and you can actually interact with the client using our web API. So, and then the Slack servers talk to the Slack client using a socket. So you can actually abstract and provide a lot of security using this model. But your code is not installed on the Slack client. Just want to make that sure. So now let's talk a little bit about bot interactions. When people say bots, they think an entity that has a conversation with me. They start thinking NLP. And it's not necessarily the case. So we'll go through a few use cases and see where NLP and AI might make sense, and some simple use cases that it might not. So the first type of interaction, bot interactions, are notifications. Notifications are an easy way to pipe content into Slack. In this example, we're using the Calendar API to pipe content about my meetings. Why is this useful? Because I don't need to do the context switching between my Google Calendar and Slack. I get my notifications into Slack. It also improves transparency and actionability, because think if my team sees this notification, they know not to ping me. They know that I'm in a meeting. Think of a message that is sent by email to all of your DevOps versus a message that goes in Slack. A single message makes it actionable and more transparent about what happened and what are the actions that we need to do in order to resolve an issue, for example. Does that make sense? Awesome. At the technical level, notifications are very simple. They are a URL that you expose to you. You hit that URL with a certain payload and resurface that information inside Slack. So as you can see, you can actually use a curl command to call and create a notification inside Slack. It's as easy as a curl command. The second type of interaction that we've seen is slash commands. Slash commands are an easy way to use Slack as the command line for a third-party service. In this example, we work with Foursquare to surface locations around for lunch and business. As you can see, you do slash Foursquare business lunch in Miami. We hit the Foursquare servers, and what they return to us is that what we show in Slack. So at the technical level, it's an API that you expose to us. So the user hits the slash command. We hit your endpoint and send you all the information, like who is the user, what's the team they're on, what is the URL, what is the query string that they added to the slash command, and what you reply to us is what we display in Slack. And this is a simple example about how to show hello with the username. The last type of interaction is actually a conversational interface. And this is a full bot conversation. And this is very interesting because you can actually facilitate a lot of interesting business use cases using bots. In this example, we work with Howdy to facilitate stand-up meetings. Are you familiar with stand-up meetings? So we stand up and we say, what are we working today? What are we working on tomorrow? What are we blocked on? And that happens all the time. And it's really easy in small teams that work together, but it becomes much, much harder when you have big teams that are distributed around the world. So Howdy actually goes into each of the team members around the world in Slack and asks them, what are you doing today? What are you doing tomorrow? What are you blocked on? And reports that back into Slack. So taking something very simple and automating it through a conversation actually makes a lot of sense in this case. Building bots is not as easy as building a slash command or notification. So we partnered with Howdy to create an open source Node framework for building bots. And even if you're not familiar with Node, you can see more or less what the bot is trying to do. In this example, it's looking for hello, hi, or greeting in a way of direct mention, or direct message. And what it does, it replies with hello. So we actually took the aspects of conversation and made it much easier using this Node framework. And I highly recommend you check Botkit. On top of that, we released buttons. And I've never been so excited about adding buttons to a feature since we did this. Buttons are amazing because they let users take action inside Slack. In this example, Greenhouse, you want to approve a request for a candidate. You click on the button, and the message changes. So you can actually create this illusion of an app, or not an illusion, an actual app that lives inside Slack, and users can take action inside Slack. Think how awesome it is to get a vacation approval queue just by clicking on a button, or doing your expense just by clicking on another button. These are, and these go over all of the types of interactions that we talked about. You can have notifications with buttons, you can have slash commands with buttons, and you can have full-fledged conversation with buttons. To summarize, we have 3 types of interactions that we've seen this year: notifications, easy way to pipe content into Slack, slash command, using Slack as the command line for other services to query and take action, and then full conversation, and that facilitates workflows. And augment all of these with actionable buttons, so users could take action inside the conversation interface. So let's talk about a little bit about use cases that we've seen. The first use case is the CRM. That was the most requested use case we've seen from our clients, the most thought over integration. And as you can see, the bot actually augments the human conversation. So you can talk in the sales channel and have the bot actually provide good information inside the sales in context. So you don't need to go from Salesforce to Slack. It actually augments the conversation. The second type of interaction that we've seen is with task management. So Trello has created an awesome integration that you can actually assign time to tasks, and you can connect to everything that you can do every day, the small interactions that you have in Trello inside Slack. But what if you want to build your own integration? What if you have your own process? You don't connect to a third-party service, but you have your own process. So in this example, Meetup.com has created their own process, in this case, for getting backlog from a conversation. So we're talking in Slack about all these cool features and ideas. They've implemented a slash command to add ideas to a backlog, to add tasks to a backlog. And this is actually powered by functions. So you can actually create, not only use apps and integrations that come out of the box, you can easily create your own workflows that are specific for your organization and enterprise. And that's you. Thank you.
So I just want to show of hands here. Who has actually tried building some sort of bot? Oh, wow. OK, this is great. This is really good. OK, so we're going to go over how you can build bots using Google Cloud services. And the first thing I want to talk about is two concepts that I want to get to you. One is the concept of serverless, and the other is the concept, and then I want to introduce some of our machine learning services. So let's first start with, serverless is a big buzzword, right? So I want to first start off with a definition of serverless. So what is serverless computing? Serverless computing eliminates the need for provisioning and managing individual servers. It's not any more. It's not any less, right? But the reason why this is important is because an inordinate amount of time for developers and operations is spent on this activity. No manager or CEO said, "Thank you for managing my servers last year," right? So serverless is, even though it's a buzzword, it actually has a lot of financial implications. The other thing about serverless that people don't understand is that serverless is fundamentally your stack reimagined and simplified, right? In this scenario, you don't care about things like load balancers. You let higher level services take care of it. Even how you write your applications are very different. Code that used to live within your business application suddenly moves out. So why don't I just kind of give you a little overview? So if you have synchronous requests or asynchronous events, they're going through some sort of pub/sub mechanism, and they get picked up and sent to the function of service. Synchronous requests are going through some sort of API gateway. Now, these are the API gateway is optional, but in reality is that if you build any production system, you're probably going to need an API gateway in front of it. The function of a service is where your actual code execution occurs. And I'm going to use this, again, a lot of terms here. A backend service or your database service is where your application store happens. So I want to deep dive into a function as service and backend service. So a function as service is very simple. It's basically a place that you can upload code, not a virtual machine, right? You're not uploading a virtual machine. You're just uploading code. It's event-based. There's monitoring built in, and you're paying by every request. Now, I want to first talk about the first part, uploading code, right? So uploading code versus a VM is very important because it allows the cloud provider to optimize the system to run your application. So today, maybe if your application might be running on an Intel processor, and tomorrow it might actually be running on an ARM processor. Those kinds of things that's only possible if you give the ability for the cloud provider to optimize your code for the given compute platform. Now, there's some gotchas. The biggest gotcha is you don't have access to the file system, right? You have to make your application stateless. And the reason why is because it enables the cloud provider to spin up your function more quickly, spin up a new instance quickly, which enables things like auto-scaling. But not having access to the file system is kind of tricky because code that used to work, aka things such as loading configuration files from the file system, things like disk-based caches, things like installing your own logging system, right? Those suddenly don't work within a function as a service environment. So you have to rely on different mechanisms to do things that you used to do. The second concept I want to introduce is a backend service, or what people call a database as a service. What differentiates let's say, a database as a service versus a truly serverless database as a service versus something like Cassandra or MongoDB is that each of the databases underneath the hood are multi-tenant. These are usually NoSQL. Though if you looked at our announcement about Spanner, it's the first horizontally scalable relational database. That's rapidly changing. And there's going to be logging built in, and you pay by request and storage. There are some gotchas, though. Usually with these kind of databases as a service and or backend as a service, you have limited ability to configure your indexes. All right. So you don't have. So this is going to be impacting you if you have some extremely low latency requirements, or you have a very, very complex query. There's times that you won't be able to use a backend as a service to fulfill that capability. We have three different types of for Google. We have three different types. We have Cloud Datastore. We have Firebase, which is our mobile backend as a service, which actually leverages underneath the hood Cloud Datastore. And we also, if you need to run a backend as a service in your own data center, we also have Apache User Grid. And that's being used to run a lot of enterprises as well. So let's give you an example of this from a scalability standpoint. Pokemon, when they first came to Google and they said, OK, we're going to launch this game. And it turned out that after a couple of months, they were doing 50 times the traffic that they originally thought. So these systems are very, very scalable and very good, especially for apps that you don't know if are going to take off, right? All right, so recapping the benefits of serverless. Number one, it's much lower infrastructure cost, right? Because you're getting economies of scale. You will have a lot lower operational cost because a lot of the routine things like auto-scaling your application or adding more servers, things of that sort, you're going to let the cloud provider provide that. But most importantly, I think this is a part that people don't think about serverless. It's a much more simplified programming model. That means that even though your code has limitations, it lets you run faster and execute and build your code faster. You focus on the code. So I want to talk a little bit about the machine learning services for building your bot. So Google has a lot of different machine learning services you've probably already heard about. And if you think about it, it's actually segmented into two categories. Machine learning services that already has the model built in, right? So you don't actually have to pre-train any model. And machine learning services where you bring your own data, you bring your own model, namely cloud machine learning. But before I'm going to dive into which particular service you need, the first question you need to ask yourself is, do you really need AI? Earlier, you saw that there were three types of interactions: notifications, /commands, and then full conversational bots. The reality is, for notifications, you don't need AI, right? I mean, there's an event trigger that tells, it's a one-way communication that tells a person something has happened. You really don't need AI. For slash commands, if it's a very simple command, right, you probably don't need AI. But if you have a command that is taking in multiple parameters, for example, in this case, it says business lunch in Miami, and your system needs to be able to react to that, having AI, namely natural language processing, helps. It also helps with dealing with things like spelling mistakes, fuzzy matching. And then for full-on conversational bots, you definitely need AI, because people could say anything. You can't create some massive if-then-else statement and expect it to work. So what is natural language processing? It's very simple. What it does is that it takes unstructured text, right, unstructured conversations, and turns them into machine understandable user intents, right? And very aptly named API.ai is using AI to turn a human conversation into a application programming understandable, something, turning it into an API. So that's a very, very good name for that particular product. So when you pull it all together, you pull the architecture together, you have your clients on the very left-hand side. They're going to be talking probably to some API management, API gateway that takes care of the things like security and authorization, things of those sort. Your application code lives in your CloudFunctions. Your application data lives in something like Cloud Datastore. And the business logic would talk to the machine learning services to interpret what the user is saying and give back user intents. So we're going to have a quick demo here. And for this demo, Amir is going to help me. I decided I want to build a bot that kind of solves my problem. And one of the things I really hate about bots, about conversations via text, is sometimes when you're in chat, you don't quite get a lot of emotion in chat. It's not fun. Like you do your daily work. It's not fun. Sometimes people like me, we're not that great with emojis. And so it's hard. It's kind of, you sacrifice a little bit of fun. The second thing that really hurts me when I'm in chat is when I'm on a deadline, something I say to my teammate may come off as really harsh criticism. So for example, like, I need to, if I'm getting a deadline, if it's meeting a deadline, I'll just say, you missed the deadline, something of that sort. I often say things that are extremely curt and it can be misinterpreted for criticism. So can I create a bot that makes these conversations a little bit more fun? Can I create a bot that would tell me if I said some boneheaded thing that comes off as criticism? So I decided to create something called KeanuBot. And what KeanuBot does is that he looks at all the conversations and tries to figure out a phrase from a movie, classics like Point Break, right? That would either liven the conversation or be able to take the sting out of bad, curt remarks. So I'm going to actually, can you switch to the demo? And Amir will demo with me. All right, so I might say something like, hi, Amir.
Hello.
How are things going?
I'm going to answer my typical answer. Amazing. Whoa. Or I might say, my car broke down. Oh, bogus.
All right, so let's take another example. Like Amir and I were interacting on some on this next presentation, and I'm like, oh my gosh, Amir, you missed the deadline for submitting your draft to legal. Yeah, and CanuBot is just reminding me that, okay, maybe that's a little bit too harsh. Right, I gotta tone things down, right? And so, okay, so let's kind of go back to the slides. I want to actually show you the architecture and how that works. So what I just showed you is the Slack. I'm going to go through the Slack client, talking to the Slack server, talking to an API gateway, which is Apache's API gateway, talking to CloudFunctions, talking to API.ai, and giving back response. All right, so let's go back to the demo. So I want to show you within Slack, there's a UI that you can use to create a bot. And within the bot, what you do is that there's a section called event subscriptions. So I'm going to set the event subscriptions to send events to this Apogee gateway. And within this UI, I can also set which events to subscribe to. So events might be like posting new messages, but it could also be other things like a new user joins the room, or a new user got kicked out of a room, right? And so your bot can react on different ways to that. So in this kind of scenario, I basically subscribe to all the messages going to the channel. The next part I want to show you is the API proxy. So the API gateway. And in the API gateway, you can create one or more API proxies. In this scenario, I created this CanuBot event handler, and if I go into it, oh. Let's redeploy. Nothing like trying things out in production. So what you have here is that it shows the URLs over here, and it points it to a particular endpoint target. What also you can do too, and I hope that this is not going to break on me. Give me 1 second here. Oh, actually, you know what? I'm not going to play around with that. So what I'm going to actually try doing is I'm going to try deploying a filter. So what the API management system does is that you could do things like spike arrest filters, which prevents your bot from getting flooded with too much traffic, or you can apply things like security, like OAuth 2. So this is kind of the example of application security code that may have lived in your app before. It's being moved out of your app into higher level services. Let's put a spike arrest filter on here, and let's set it to 10 messages per minute. Okay. All right, so it's submitting it. While that's happening, I'm going to show you CloudFunctions. So CloudFunctions, this is the console. Any CloudFunctions you deploy will show up here. You could literally have hundreds of functions. That's the great thing about this. And you're not going to be charged for the functions that are not running. Right? It will be spun up on demand. And we could take a look at the logs. All the CloudFunctions by default has a logger built in. And you can see here, like the last message that was coming through, how are things going? Things of that sort. They all show up in the log message. Let's just double check to make sure this stuff works. Okay. All right. Let's see. Let's hope it still works. I'm going to actually introduce a bug in the system and show you how a deployment goes. So inside this CloudFunctions, to write a CloudFunctions is very simple. You basically write a function over here. It looks exactly like an Express app because underneath the hood is actually leveraging Express. And then you basically export that particular function. Now, I'm going to put there's a little code in here that actually causes CeanuBot to ignore all the requests that are coming in from itself, right? Because CeanuBot is only supposed to monitor human responses, and I'm going to introduce this bug over here, and then I'm going to deploy it to just show you how deployment works. And it typically takes under 2 minutes to actually get a deployment happening. So while that's happening, I want to quickly show you what's going to happen with this bug. So this bug is going to cause the bot to go into infinite loop. And the reason why is because this I created in API.ai a set of intents. And one of the intent is this whoa intent. So this whoa intent, basically what it says is that if it ever sees a message called whoa, it would respond back with whoa as well with a picture of Keanu Reeves. So let's try this out, and let's see if it works. Start tracing the session. Okay, let's just double check to make sure it's deployed. Okay. And then all right, so now it's going into its infinite. It went into an infinite loop. So let's take a look at what happened. So one of the cool things. Oh, give me 1 second here. Again. All right, well, I'm having some issues with the UI for the API management system. But what's happening here is actually, if you look in the logs, you can see that it was sending whoa, whoa multiple times, and then eventually it stopped. Because what was happening was, at the API gateway, we had set a spike arrest filter, and it basically was able to block that flood of messages coming in. So before that, let's go fix the code and redeploy. And while that's happening, I want to show you how you can use API.ai to create a new intent on the fly. So I'm going to create an intent. You know, inside the Slack channel, a lot of people ask, like, how do you do this? Or, I don't know how to do that. So I might say something like, does anyone know how to do something, right? And whenever somebody says this, I think about the Keanu Reeves quote in Matrix, where he says, "Oh, I know Kung Fu." So we'll take this picture, and we can put it in the text response. And we'll save this, and we'll save it here. And once we create the intent, we can actually try it out within the API.ai UI. So it doesn't have to be exactly the same. I'll say something like, Amir, do you know how to fix my Slack code? Does anyone? Oh, okay, so it didn't get, it actually matched to a different one. Let's try something else. Does anyone know how to fix Slack? Okay. Oh, you know what? I forgot to press save. Oh, what's going on here? Okay, it just took a little bit of time to actually get through. So you can actually test within here, and what you see here is that it's able to match the particular intent, and because it's not an exact match, it actually gives you a score. So this gives you a confidence of how confident your application actually matched that particular phrase. And within your code, you could basically put a match filter. And I said if it matches more, if the score is higher than 0.5, then it would actually return. So if we actually go to the code, say, does anyone know how to debug Visual Basic? And it pops up.
Awesome.
So, Amir, what do you think about this bot that I created, and just give me some comments and feedback on it.
So first of all, I think it's awesome because it augments conversation. So it actually addresses your problem, which is like sometimes we say things in text that we don't know how to interpret with other people, right? And it adds a layer of this awesomeness. What I would suggest moving forward is maybe having the bot answer these awesome replies in threads. So you can actually have the conversation going, but actually have the bot respond in threads so that it doesn't disturb our conversation. We can have our conversation in line, and if we want to have this interpretation of the bot and what it does say about what we're saying, we can click on the threads and see what the bot is saying. Do you understand? So that could be a nice addition to your bot.
And you know, like I just showed, there was a lot of like little errors here and there. What are some practices do bot builders deal with if there's a misinterpretation? Or what are some strategies around that?
That's a great question. I think one of the key things is read your logs. You will see that users say and interact with your bot in ways that you didn't think are what wasn't the use case that you thought. People ask bots about Trump. They ask bots about the weather. They ask Trump about anything. I even found two founders that actually mapped the amount of times people said, "I love you," to the bot. Think of it, because this is an interaction that is very humane and very intimate, people really tend to have emotion responses to the bot. So don't be surprised if your bot actually delivers on what they want, on what it does. It will get a lot of love from the users.
Okay. All right, so let's go back to the slides. We're almost to our end. So I'd just like to remind you that if you like this presentation, or you didn't like it, we have two more presentations, one on API.ai, and then one on how, instead of building a Slack bot, you're going to be able to build a chat bot, how to build a voice bot. So with that, let's have some questions. The question was, why did I choose CloudFunctions instead of App Engine or endpoints? So the reason why I chose CloudFunctions is because it was just so darn easy to do. And the truth of the matter is, App Engine, actually the code that I just showed you, that same code runs on App Engine directly as well. Some of the nice things is that if you run it on CloudFunctions, you don't have to pay for when the app is not running. And also it scales very, very quickly as well. There's, underneath the hood, they've done some optimizations to make it scale, and it's cheap. Endpoints actually is also an API gateway. And I would actually say that if you have enterprise use cases, especially if you have multi-cloud enterprise use cases, Apogee is the way to go. And Apogee also provides other API management capabilities, like creating developer portals and more complex ways of doing, it has more complex policies as well. Endpoints, on the other hand, it's cheaper. I'll be honest here, right here. But it's also designed for Google's infrastructure. So if you have an app and your APIs are all within Google itself, API endpoints Cloud Endpoints is a great solution.
Hi there. We tried to build a small bot in our company, and one of the issues that we faced was names recognition. In particular, we wanted it to, and with API.ai, we wanted it to recognize people's names. And the issue is that names can be foreign, they can be objects that already exist in the system. Are there any strategies for actually distinguishing names? Do you aggregate everything from the corporate directory and stick that in as a name? I mean, what are some things that you can do to help?
So there's a few strategies to handle that. We have sign-in with Slack. So when a user installs the app, you can actually get his email, his team, his name, or her name. You could also use our API to list the users in the team and get all the information, all their profile information on them.
I'm sorry, I didn't clarify. Voice-based. For
Oh,
the
voice-based
Yeah,
application.
yeah, voice-based.
That's a good question.
That's a hard question. So if we could actually go back to the demo. So this might not clarify everything that you said, but when you create an intent, say a name intent, my name is Alan. What it does is that automatically recognizes the name. Now, what you can do is you can create multiple variations of this, and basically, Alan is my name. What ends up happening is that it gets smarter. It gets smarter by having multiple of these phrases in there. So you just basically have to figure out the corpus of kind of phrases that may have a name in there, and you can add them in, and then that way it will be able to better pull out the name. I know that doesn't work all the time, but that's maybe one strategy you can use.
All right, thanks.
Any other questions?
So the question is, are engineers biased? Are we using engineering speech when we're doing speech recognition? And the answer is yes. I'm an engineer, so I can say it, but I think us as engineer, we have natural language understanding problems. Right? It's true. It's something that we have. So I think having someone who's an actual designer, a conversational designer, is very important. Having a script writer. So for example, Hi Poncho, which is a bot that helps you do the weather, they actually hire people who are doing conversational designs. They have scripters who actually, and they have a CMS, they have content management system that actually maps conversation and what the bot will say. Yeah, let's not have engineers create the scripts. Let's have designers create the scripts. Okay.
Why don't you repeat the question?
So the question is, how do you set expectations? What can the bot do or not do? I think the key in Slack is around onboarding. So when you onboard an app or a bot, the key is to let the team know what the bot could do. Think of, and it's the same thing with like humans. So when you onboard legal aid to the team, what do you say? You say, hey, everybody, we have this new legal aid. They could help you with legal questions. And you can use the legal channel to communicate with her or him. It's the same thing with bots. So you can actually script an onboarding script that lets the team know how to use the bot and what to expect. The second thing is to handle errors and feedback. So there's a lot of things that people would say to the bot, and they will ask it, they will play with it. Because this is a new user interface, people like to play. So just manage expectations. Don't try to do, for example, don't develop chit-chat model. A lot of developers which I've met try to like, hello, how are you? What's the weather? How have you been doing? That's a total waste of time. Be very, very clear with what the bot does and have a single purpose bot that solves one thing, and people would hopefully love it.
Another suggestion is that, especially if you're trying to deploy in an enterprise, don't always, you might have a 50-50 model where the bot answers 50% of the questions and the human answers the other 50%. So an example, another use case on the Apogee website itself, we created a bot that would majority of the time actually be answered by an inside salesperson, right? Like if somebody's asking for a pricing sheet or needs to sign up for a demo. But for the things that are very, very common, like how do I implement OAuth, the bot would actually, the application would actually intercept that message that's going to the inside salesperson, reply back immediately to that person with an answer that's suitable. And to the user, it looks like the inside salesperson is actually making the answer. So that way you can actually kind of you can create, you can intercept messages at a very, in that scenario, you want to make your AI system intercept very, very specific messages and fall back to the human majority of the times, because a lot of times we just haven't planned for it. And that way you can over time gradually train up the bot to add more and more new functionality.
I agree with that. Maybe last comment on that is that not all bots are conversational. Again, this is very important. Most of the bots I've seen are notifications and business workflows. These do not require a lot of conversation. It's just getting good things done. So it's a matter of you can facilitate a lot with buttons and rich interaction, and then the process becomes much more intuitive for your users. Yeah, definitely. So this is called DM, direct message, and a bot could DM any user. So what I would see is you start doing these sentences inside a channel, and the bot analyzes this. We should implement that idea for the KeanuBot, right? And then the KeanuBot could give you in a DM interpretation of what you said, right? This was too harsh, right? So you can actually implement a way where the bot listens to the channel, but gives you feedback in a direct message. No. Yeah. Sorry. Yeah. And sorry. Wow.
Repeat the question.
I love all my bots. I love bots that facilitate business processes. So, for example, I ask this in every event, so I'm going to ask this here. How many of you like to do expense reports? Not a lot of people raise their hands. And why is that? Because if you think about doing expense reports, it's actually should be an awesome experience. I paid for something, and now the company is paying me back, right? We should wake up every morning wanting to do expense reports. But if you ask VPs, they don't mind doing expense reports. Why? I paid for something, and now my personal assistant helps me and makes that pain go away, and then I get paid. So think of all the business processes that are sucky, for lack of any other name, in the business in your business life, and see how you can implement them using simple workflows. Most of our business processes are in spreadsheets or VB script, God forbid. You can actually take a lot of these processes and implement them in a conversation interface, and that makes a whole lot of difference. I hope I answered your question without naming one son over the other, who do I like, and stuff like that.
My favorite is actually Audible. So I like listening to audiobooks, and I just find it very easy to just ask Audible to open a particular chapter and have it start reading it to me. So that's my favorite. Repeat the question.
So the question was, what do you do with multilingual bots? And I would say, as an engineer, I don't know what the right answer is right now. I think this is uncharted territory. I played a little bit with API.ai, and you can train it to give it different languages for the same intent, and that works for some extent. But think of a place where different people in the channel speak different languages. So I'm saying that I hear you. I don't have a good answer, but I think as an industry, we're still learning this thing. You could use API.ai to do the trivial mapping of this sentence in English, and this is how it is in French and in Russian. So that's a good way of going at it.
Yeah, we also have a translation service as well, and there's amazing AI in the last year that's helping these translations get really good. So I think it's going to be interesting because these translation services are today basically reading a lot of human text from articles. But as Google sees more and more bots built on its platform, and it's seeing a lot of chat coming through, you're going to start seeing. I predict that these translation services will even be very good for chat as well. So we're at day 0.
Yep.
So the question was like, especially in a kind of a serverless architecture, how do you go about testing? What is the application life cycle going to be like? Well, actually, a lot of this is, you think about it, this is really more towards a microservices architecture, where a lot of the concerns that used to be bunched up together in one big monolithic application gets broken up into a lot of apps. So I would say the first thing you want to do is having a lot of unit tests against every single microservice and really figuring out what your bounded context for each microservice actually does. So I think that's like step 1, figure out the right architecture for your microservices. And then step 2, around the life cycle of it, I would just treat it like any, there's tons of books on best practices for microservices lifecycle. I would treat it just like that. I would treat every single one of them. You want to make sure that every microservice that you put into production, you have a rapid process to be able to deploy new. You have the ability to roll back. Blue-green deployments, all that good stuff that we've been developing over the years.
Thank you. So the question is, how do you see the bot world evolving with bots not being in your face or like making too much noise inside Slack? So I think, again, it's a learning experience. If you think about the first web pages, they had all these flashing texts. You remember the HTML text? Everybody used animated GIFs and flashing text in every page. I think we're a little bit in that era, and I think we're learning. So I think in the last year, we've worked with a lot of bot builders to actually make the onboarding great, doing less chat, not DMing everyone. The other thing is that you can turn on admin approval apps, which means that only administrators can install bots. So users can still request bots. So they could go into the app directory and request a bot, but that goes into a queue where the admin can approve those. So if you're seeing too many chatter in your Slack channel, then I would turn that on. Last thing is company culture. For example, in Slack, when I talk about a certain topic off topic in channel, if I go to the marketing channel and start talking about code, people will react with a emoji that is a raccoon. That tells me that I'm speaking about the wrong thing in the wrong channel. So having cultural things like that to signal, hey, why did you install this bot, is a good best practice. No. We're very far. So the question was, how intelligent can the bot be? Can the bot have a discussion with you about the architecture and that connection to design? And the answer is, right now, no. The word intelligent and artificial intelligence is marketing speech. It's like the AI is an amazing tool, but bots are not sentient, and bots are not intelligent in the way we perceive intelligence. they're more smart. I would call it artificial smartness. Because once you teach something to a smart person, they know how to do it better. But there's no intelligence, at least then, and I'm sorry, maybe soon the overlords will take over and take over the world, and then I'll be punished for this, but this is my opinion. What you can do is actually facilitate workflows, and that's where the sweet spot of bots are. So I need to approve a design. So having the post the design in channel and then having a button that says approve instead of sending 10 emails, that's where the bot excel. So you know the reply all nightmare? You send an email to a team and everybody's starting replying all. You can actually make that go away with a bot in a very easy way. So these are the use cases. Think of the small use cases that you can implement that are contextual and save a lot of time.
Your job is safe. Any other questions?
Thank you
All
very
right,
much.
thank you very much.
Thank you.